Let us start the new topic, thermal stresses. As the name suggests, these are temperature stresses, means the stresses which are developed due to change in temperature. The temperature may rise or fall, and due to which there may be stresses developed in the material. So suppose we have a bar of length L and we have increased the temperature of this bar. Suppose the temperature of a bar is increased by T degree centigrade, right? So this is the rise in temperature of the bar. And due to that, there is natural tendency that when you increase the temperature of a bar, it will try to expand. So its intention is to increase the dimensions, and suppose the dimensions are increased by delta L. In the opposite way, we can write that the same bar, for the same bar, there is some decrease in temperature. Say T degree centigrade, there is decrease in temperature. And the natural tendency is to reduce the length of the bar to shorten the bar. So suppose the dimensions decrease of this bar is delta L, and the same length was the L was the length of the bar. So on what factors this delta L depend? This change in length depends on what factors? So from experiments, it is observed that higher the length, higher will be the deformation in the bar, whether it is expansion or contraction. And higher the temperature rise or fall, higher will be the change in dimensions of the bar, right? So it means the change in length depends on two factors. One is the original length of the bar and another is the change in temperature of the bar. So delta L is either proportional to length of the bar, and delta L is also proportional to temperature of the bar, change in temperature of the bar. This is change in temperature. If we combine these two terms, we will get that delta L is proportional to LT, and if we remove this proportionality sign, we will get a constant. So removing this proportionality sign, we will get delta L equal to some constant alpha. This is alpha, this is proportionality sign. These two seems same but are different things, right? This is proportionality sign alpha, this is the coefficient of thermal expansion, this is a constant, right? Alpha LT or L alpha T. This is written in different terms like L alpha T. So this is the change in length of the bar due to rise in temperature T degree centigrade, right? And this alpha is constant, and alpha is a constant which is called coefficient of thermal expansion. Coefficient of thermal expansion if there is rise in temperature, or contraction if there is fall in temperature, right? So what are the units of alpha? So alpha can be written as, from this equation, suppose our main equation is this. So from 1 we can find out alpha is delta L upon LT, delta L upon LT, and that can also be written as delta L upon L, which is strain, upon T, which is the temperature change. So alpha is defined as change in length per unit rise or fall in temperature. So delta L, the alpha can be written as change in length per unit length per unit change in temperature. So this is our alpha, change in length per unit change in temperature. So what will be the unit of this alpha? The unit of alpha will be equal to change in length. It has units of meter, per unit length meter, per unit change in temperature, rise or fall in temperature. This is degree centigrade, right? So meter cancel. So alpha will have the unit of per degree centigrade. And because the change in temperature may be Kelvin, may be degree centigrade, we can also write this is 1 by Kelvin. So this is the unit of alpha, per degree centigrade or per Kelvin. So these are the units of alpha. We have found that delta L is equal to L alpha T. This is the change in length due to change in temperature. Is it okay? Now, what is the strain developed in the material? If there is change in length, there must be some strain in the material, which is change in length per unit length. So strain developed in the material will be equal to delta L upon L, change in length upon original length, and that will be equal to L alpha T upon L. So L to L cancel, this will equal to alpha T. So this is the strain. This is the strain developed in the material. Strain developed in the material. And more precisely, we can write thermal strain. Thermal strain, because it is this strain is produced due to the change in temperature. That's why we are saying thermal strain. So this is the strain developed in the material. But we are more concerned about the stresses developed in the material. What are the stresses developed in the material? So there is some change in length, and this change in length, there is free expansion of the body. So if there is free expansion of the body, what is happening? Free expansion. And what we mean by free expansion? It means that we are not restricting the deformation. If there is no restriction on the change in length, the body is expanding freely. So we have to think about that. Why the stresses are developed in the material? The stresses are developed in a material if the expansion is restricted. Suppose we want to do some work and there is some restriction that we cannot do that work. It means some stresses will be developed in our mind. Similarly, here also, if we restrict the deformation of the material, there will be stress developed in the material. Otherwise, there will be no stress developed in the material because we are allowing it to expand freely, right? So, if we are allowing it to expand freely, there will be no stress developed in the material. So, in free expansion, no stress developed. No stress developed. It means sigma will be equal to 0, right? But what if have a rigid support here which do not allow to expand this material to its limits, right? So what will happen if we restrict the expansion of this body? Suppose we have same body we are making which has L length, and there are rigid supports. These supports are not allowing this material to expand, right? So there is no expansion in the material, but natural tendency is to reach here. Its natural tendency is to reach here, but there is some forces. These are the forces imparted on this material so that this expansion is restricted, right? So this was the delta L, which should be the length of this material in case of free expansion, which is given by L alpha T, but we have restricted this material. Now, because we have restricted this material, there will be some stresses developed in the material. And in other sense, we can say that there are some forces, say these forces are reaction of this body and this rigid bars. Thus this R is restricting this material to not to allow the expansion of this body to delta L. It means we can say here this was a free extension, that there was no stress. Now there is expansion is restricted. Expansion is restricted, and we are going to study this. Expansion is restricted. We have restricted the expansion, and due to this restriction, there would have been, if there is free expansion, L alpha T would have been the expansion of the material, but due to this reaction, due to some external forces, this reactionary forces, there is change in length of this material, and we know from basics what is the change in length given by if there is some external force, and this reaction is taken as external force. So we know the formula PL upon AE. PL upon AE. So we can write this delta L is also equal to P. P here is the reaction of this supports, so we are saying R L upon AE. And what is force per unit area? Force per unit area is stress, right? So we can write sigma L upon E. So these two equations are same because the change in length L alpha T would have been the free expansion, but this reaction force is causing this material to compress. So sigma L upon E. So what type of forces exist in the stress developed in the material? Because this is compressed by this amount, so compressive stresses will be developed in the material sigma C. Sigma C shows the compressive stress. So we can write this L alpha T is basically equal to sigma L upon E, or from here we can find out the stress developed in the material, and this is compressive in this case. We are generalizing the case sigma L cancel, we can write alpha TE. So we have seen two cases when the expansion is not restricted and when the expansion is restricted, right? So we have seen that one case is free expansion where there is no support to restrict this expansion, and there is some expansion in the material, and this expansion is given by L alpha T. This is the expansion in the material, and L is the original length of this bar. Another case is expansion is restricted. Expansion is restricted. In this case, there is some support, rigid support is there, and the body's tendency is to expand, but due to this reactionary force, the body is not able to expand. If it would have been allowed to expand, the expansion would have been L alpha T, but it is not allowed to expand, right? So this is one case, this is another case, right? In this case, there is no stress developed, but the strain developed is this much per unit length, right? So we have seen that strain will be equal to change in length upon original length, and this is L alpha T by L. So this is equal to alpha T. So strain developed is alpha T. And there is no stress developed in the material because we have allowed the material to freely expand. So this is the case. You can see thermal stresses are different type of stresses in which there is strain but no stress. There is strain but no stress. Another case is expansion is restricted, right? So we have seen that there is some force, reactionary force, which is causing this expansion, and this full expansion is restricted, right? There is no yielding of force, there is full expansion is restricted. So we have seen that this expansion which is restricted, and from basics formula delta is PL upon AE. This is our main formula, PL upon AE. So we can write that this L alpha T must be equal to RL upon AE, which is equal to sigma L upon E. So we have found out sigma from here as alpha TE. This is the stress developed in the material. stress developed, and in this case, in this particular case, the stress developed will be compressive because reactionary force has compressed this material. So stress developed will be compressive. But what is the strain developed? How much is the strain in this material? There is no deformation in the material actually, because this L alpha T is restricted. So strain will be 0. So simple stresses, in simple stresses, the stresses are developed due to straining of the material, but here the case is reverse, that when you have strain you don't have stress, and when you have stress you don't have strain. So this is the two cases, free expansion and expansion restricted. The full expansion is restricted. Now in next topic we will study what if there is some yielding of spores, that the expansion is not fully restricted, there is some yielding of these supports due to loose connection. What will happen then? So what will happen if the supports starts yielding, right? So thermal stresses when supports yield. So let us take the case that there is some bar, and this bar has length L, and there are some supports, but when we apply the temperature, when we increase the temperature by T degrees centigrade, there is some yielding in the support. This is the free expansion if we allow this expansion, but this supports due to loose connection starts yielding and it moves a distance. Suppose the supports move a distance, say delta. So this delta is the distance moved by the supports, the yielding of supports, right? And if we allow free expansion, then this would have been the free expansion, which is equal to L alpha T. But this expansion, this part of the expansion is restricted. Say this is X. So there are four distances: L, which is the original length of the material; L alpha T, the free expansion, if we allow the expansion to be freely expand; this delta, which is the yielding of supports; and this X, which is the expansion is restricted, right? This expansion would have been restricted by some reactionary force of these supports, say R, right? So what are the terms here? This L is the original length, of bar, delta is the yielding of supports, X is the expansion restricted or prevented, which is not allowed to expand, and L alpha T, this is the free expansion if allowed to freely expand. This would have been the free expansion. So four terms are there, right? So what is X in this case? X, expansion restricted, that is equal to free expansion minus yielding of these supports. So this is L alpha T minus yielding of supports, that is delta. This is X, question number 1. And this X is also prevented to expand due to this reactionary force, and from basics we know that delta L would have been PL upon AE. Here P is the reaction force by these supports, which is R, and L is the original length, A area, and E is the modulus of elasticity, right? So this delta L is basically the X, the expansion which is restricted, right? So X is also equal to RL upon AE, and force upon area is stress. This is equal to stress upon E. So this is also the expansion restricted or prevented 2, and 1 will be equal to 2. So we can write that L alpha T minus delta will be equal to sigma L upon E. So from here we can find out the stress in this material when there is yielding of the supports. So stress will be equal to, sigma will be equal to L alpha T minus delta by L multiplied by E. So this is the stress developed in the material when the supports are yielded. And what is the strain developed? Strain is the change, expansion in the material per unit length. So strain will be equal to, there is only this expansion for which the supports are yielded. So this delta upon L, this is the expansion in the material, right? And this delta can be written as, L alpha T minus X, L alpha T minus X upon L, where X is sigma L upon E. So we can write epsilon would have been equal to L alpha T minus this sigma L upon E, sigma L upon E by L. Right? So L and L will be cancelled out. So strain in the material will be equal to alpha T minus sigma by E. So this much is the strain in this material. So this is the case when there is yielding of supports and some of the expansion is restricted or prevented, right? So it means in this case both stress and strain obtained. This is the stress obtained in the material and this is the strain, or this is the strain in this material.